Remember that our goal for today as you are plotting linear relationships is really to be able to use a table and an equation interchangeably to help you graph something. So sort of 4 basic steps I'll follow, and if you hear some growling in the background, that's just Axel, my dog. So you can say hello to him if he barks at you. So the 4 basic steps I will typically follow is I will start by drawing a coordinate grid, then creating a table of values, then I'll plot those actual coordinates, and then I'll connect using a ruler. So let's say, for example, I'm given an equation, a linear equation that follows or linear relationship that follows this equation. So y equals 2x minus 2. And so what that says is that I know I can determine my y value if I multiply my x coordinate times 2 and then I subtract 2. So the first thing we're going to do is create a coordinate grid. And again, we're going to sort of attend to precision by using our tools properly. So let's draw a coordinate grid using a ruler. And again, this is why I love that your math notebooks are typically in graph paper, is because it helps me do this neatly. And so maybe for this, I'll just do each individual square could be 1 unit. And maybe I'll just go down to like 5 or 6. Doesn't really matter how far down you go. Depending what you're graphing, you might find that you maybe need to extend your graph out further, out to like units of 10. Or maybe instead of each square representing 1 unit, maybe 2 squares represents 1 unit. That will be determined by the relationship that you're trying to graph. And so I'm just going to do like the first 5 or 6 for now. So I've created a coordinate grid. Check. Good job, me. The next thing I'm going to do is create this table of values. And so typically what I'll do, again, use a straight edge to help you be precise. And so I'm going to create a table that has a couple of columns in it and a couple of rows. So the columns that I'm going to create, I think this is going to be enough, maybe I need one more, that should be plenty. Great. The columns that I want to create is I want to create one column in my table to represent the x values. And so that'll be this one right here. And then I'm going to represent one column is going to be where I'm going to put in this expression, 2x minus 2. And that can go to maybe there. And then I need a column for my resulting y values. And then sometimes it can be helpful, especially as you're first learning to do this, to create a 4th column where you actually are going to put in the coordinates specifically. As you get better at this, you might find you don't need this particular column, and you can just work with these 3 columns. So to begin with, they haven't given me any values for my x. So let's just, for creating our table values, let's choose a number that's positive, a number that's negative, and maybe 0, since they'll sort of all be right around the origin right here. So let's maybe do negative 1, 0, 1. Well, I've got 1 extra. I can do 2 down there. Okay, great. My next job here is I'm going to plug in this x value into this expression, and then I will evaluate it to figure out the resulting y. And so I could rewrite this expression as 2 times negative 1 minus 2. I can rewrite this expression now using this x to replace that x with 0. So it'd be 2 times 0 minus 2. I'm going to rewrite this third one as 2 times 1 minus 2 and 2 times 2 minus 2. Again, I'm going to push you to use this structure of really writing these tables out using these expressions, because as we get into more complicated expressions, and because we're going to be using positive and negative numbers, this is where people tend to make mistakes, is the actual act of evaluating this. So this one I know that 2 times negative 1, that's going to be negative 2. Now I need to subtract 2 from that. Gets me to negative 4. This one, 2 times 0 is 0. Minus 2 gets me to negative 2. This guy down here, 2 times 1 is 2, minus 2 is 0. And this one down here, 2 times 2 is 4, minus 2 is 2. And so this last column here is simply where I'm going to put my x and y coordinates together, so I know exactly where that coordinate will be. And so this will be negative 1, comma 4. This point here would be 0, negative 2. This one here would be 1, 0. And the last one here is 2, 2. The reason, again, I will push you to use this structure is so that we don't erroneously plot it y comma x, which is pretty common when people work with this table as they start plotting their y first where their x should be, or vice versa. So using this structure of putting it into the table, now I can remind myself, oh yeah, when I actually go to plot these coordinates, I need to find -1 in my x, and, oh, that's -4. I just caught an error. That's good that I checked that. Right, over here it says -4, and over here I only wrote 4. I was about to go the wrong way. So again, that's why that table is good, is it helps you figure out, is my graph reasonable? So -1 in my x and -4 in my y means that first point's going to be right there. Maybe I'll label that -1, -4. This one's going to be at 0, so I'm not going to move in my x, but then I'm going to come down in -2. So that's going to be right here, be 0, -2. This one looks like I'm going to go +1 in my x and up 0 in my y. So it would be right there, would be that point, would be 1, 0. And this last point here looks like I go over 2 in my x and up 2 in my y. So I could label that one as 2, 2. So I created my table values. Now I was able to, because I had this fourth column over here of the x, y, I was able to very quickly plot my coordinates. And then my last step here is to connect using a ruler. And so I can make sure it runs through all those points. And what's great about this, again, since I'm on graph paper and this is a linear relationship, I know it's going to continue on at that same slope for forever. And so then if someone said, hey, what's the resulting y value when x equals 97? Well, I could continue going in my table for forever, but that feels heinous. But I could also use my graph to predict like where it would be someplace over here. Or I can use that strategy of plugging in the x value into my expression. So it's a good way you can move sort of fluidly between an equation, a table, and a graph. So big takeaways for this lesson. When you go to graph linear equations, start by creating a coordinate grid, then using a table, create that table where you figure out your x value, plugging it into your expression to then establish your resulting y value, to then establish your coordinates so you can easily plot your coordinates, and then last is connect with a ruler. And because I know this is a continuous linear equation, I'm going to draw a line and put arrows through the end of it.